Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Okay, so this is the part 2 for chapter 1, which is introduction to data structures and algorithm. Alright, what is actually data structure? It's a way of storing data in a computer so that it can be used efficiently. Okay, however, it is carefully chosen data structure will allow you the most efficient algorithm to be used. Okay, in part 1 I already mentioned that normally when we talk about the efficient of algorithm, so maybe in terms of we reduce time, okay, and so on. Alright, so a well-designed data structure allows a variety of critical operations to be performed, okay, using as few resources, okay, and both execution time and we can also reduce the memory space as possible. Alright, so these are operations to the data structure. We have traversing, okay, whereby we access and process every data in data structure at least once, right? And then we also have searching. We search for a location of data. So let's say we have maybe 10 array, okay, 10 array locations. So we are trying to search for a location of data. We are looking for maybe number 10, okay. And then insertion, insert item in the list of data. Of course, we also have deletion, to delete item from a set of data. Sorting, sort the data in certain order. And merging, meaning that merge multiple group of data. So this is an example of traversing linear areas. Okay, so we can see here that traversing is accessing and processing. Okay, we go to one array, second one, third one, and so on. Okay, these are the operations to the data structure. Okay, so the basic data types in C++. Okay, since this class we are going to use C++, so it store only a single data. Okay, so we have boolean, okay, we have enumeration, we have character, okay, char, we have integer, whether it is short, int, or long. So I believe that this one you already learned about this part in programming technique 1. Okay, and then we do have floating point, okay, float and double, but normally we are using float. All right, so basically these are the structured data types. All right, so we have state structure here, okay, whereby we have state and queue. We have link structure, okay, we have under link structure we have graph, binary tree, sorted linked list, unsorted linked list, network. And under the storage structure we have array and structure, which is struct. All right, we go one by one. All right, so for the structured data types, array, okay, array, what is an array? Okay, can contain multiple data with the same types. Okay, so meaning that we can have we can have array 0, array 1, array 2, array 3, and so on. So each of the array, okay, they have the same types. Okay, if integer, so that if a0 is integer, so same goes to a1, a2, and so on. Okay, and then we have struct, okay, can contain multiple data with different type. Okay, if different type, then we can have struct. Okay, so this is example to declare for the struct. Okay, so we have we have int age, char name, this is the pointer, right? And then we have enum. Okay, enum is for the gender, whereby we are going to have male and female only. Okay, what is enum? This one, male, female. Okay, this is an example of enum. Okay, for example here, season. Okay, so we have for the season we are going to have spring, summer, fall, winter. Okay, so meaning that we can use the enum in our class. All right, and this is state that we declare, okay, value for each of the enum. All right, and then we have a linked data structure. Okay, linked data structure meaning that just now I already mentioned we have queue and stack. Okay, in linear data structure with no restriction. Okay, this is with the restriction. Okay, with no restriction. Okay, so we have unsorted and sorted. Very simple. And the last one we have non-linear. Okay, this one we have binary tree and also graph. Okay, let's look into one by one. What is a queue? First in, first out. Very simple. Okay, it's very easy to understand. It's about when we talk about the queue, first in, first out data structure. So the first element added to the queue, so that will be the first one to be removed. Okay, for example, we go to the post office. Okay, let's say we get our number is 1001. Okay, we are the first one who entered the post office, so meaning that we are going to be the first person, okay, get out from the office, post office. Okay, all right, and then we have stack. The stack, the concept is last in first out. Okay, last in first out. For example, let's say there are 36, all right, and you are number 30, but you are going to be the first one, okay, to go from that room, for example. Okay, so this is an example for the stack. Push, pop. Okay, push and pop is a very common process when we talk about the stack. Okay, last in and first out. Okay, and then we have a linked list. Okay, this is under no restriction. Okay, whereby consists of a sequence of nodes. What each nodes? Okay, later I'll show you. Each containing arbitrary data fields and one of two references, links, which is pointing to the next or previous nodes. This is example. Okay, this one is the singly link, okay, containing two values. Okay, the value of the current node and link to the next node. So this is singly linked. So meaning that here we have the value and another pointer to link to the next node. And then the second one we have doubly linked list. Okay, in doubly linked list here we can see that there are three integers, whereby, okay, the first one of course the value, okay, and then we have the link which is forward to the next node. Okay, you can see here, and then we have the link backward. Okay, so when we're talking about doubly linked list, three, the value, forward, next. Okay, the last one we have circularly linked list. Okay, three integer values. So we have the value here, next node, but the last node will point to the first node. Alright. For the sorted linked list, data stored in ascending or descending order with no duplicates. Okay, and insertion is at the front, middle, or rear of the list. Okay, and the deletion will not affect the ascending and descending order of the list. For the unsorted linked list, a linked list with no ordering. Okay, when we talk about unsorted, or definitely no ordering at all. Okay, now we are talking about binary tree. Okay, what is a binary tree? A data structure based on a tree structure. Okay, so we have a tree structure is a way of representing the hierarchical nature of a structure in a graphical form. Okay, a binary tree is a tree data structure in which each node has at most two children. Okay, so I mean at most two children. Okay, and then used for searching big amount of data. Okay, here I have an example for a tree. So this is the root. Number 20 is the root. Okay, this is considered the root. And let's say 20 has two children, number 7 and number 33. Okay, and then number 7 have two children also, number 5 and number 10. Okay, so 5 and 10 is considered as sibling. Okay, so these are vertices. And the last node we call it as leaf node. Okay, for a graph consists of set of vertices and a set of edges. Okay, such that each edge is in connection between a pair of vertices. So some applications require visiting every vertex in the graph exactly once, right? Okay, so the application may require that vertices be visited in some special order based on graph topology. For example, we have artificial intelligence search. Okay, we have shortened path problems. We have websites containing a link to and from other websites, and also graph that represent causes and the prerequisites. I know this is very common problem, right? Causes and prerequisites. Okay, so here we have directed and an undirected. So this one, okay, the graph consists of arrow. This one we call as directed graph. Okay, meaning that we know to point to what, right? But this one is considered as undirected graph. Okay, so network is a directed graph. Okay, because we are pointing, we want to go where, from where to where. All right, so it can be used to represent a route. For example, a route for an airline, a route for delivery vehicles. So this is like one example of network that apply directed graph. So we can see here that with a network that represents a route for a delivery truck. So the road shows all cities in Johor. Okay, so we can hear Batu Pahat to Muar 45 minutes. Muar to Segamat 60 minutes. Okay, so time taken also for what a journey from one city to another. Okay, so this is considered as network directed graph. Alright, that's all for this part. See you in part 3. Bye.